Hello, and welcome to another episode of Undercooled. Today, Tim and I are in Atlanta at the NAMES meeting, the North American Materials Education Symposium. And we're lucky enough to have with us one of our favorite people, Ron Kander, who's been at every single NAMES meeting that has happened. How many is that, Ron?
14 of them.
Wow. And so I first met Ron here, and he always gives great talks, and this year was no different. So I think we'll start with having Ron tell us a little about who he is, how he got into material science, and how he went through his career. And then hopefully he'll tell us his thoughts on the future of engineering education and how materials will play a role in that, because that's what he's been thinking about for a long time.
Yep.
So go ahead, Ron.
Sure. Well, thanks, Steve and Tim. This is a great opportunity. Appreciate it. So my journey. I'm originally from Western Pennsylvania. I'm a first generation college student from the steel mill and coal mining towns of Western Pennsylvania. Interestingly, nobody in my family knew about college, but my high school physics and math teacher are the ones that said, "You're good at this stuff. You should do this thing called engineering." I said, "Okay, how do you do that?" And coming from Western Pennsylvania, he said, "Well, you go up to Pittsburgh to this school called Carnegie Mellon." I said, "Okay." So I applied to Carnegie Mellon, went there. Nobody told me you were supposed to apply to more than one college. I just applied to one place. and I got there, and all these other people on my floor had 20 schools, 15 schools. Oh crap, maybe I should have done something. So, Carnegie Mellon, my undergrad, chemical engineering. That's where I met my wife. We were first year freshman chemistry lab partners, and that's how we met. She's a chemie also. We both went to graduate school at University of Delaware. I did my PhD there. She did her master's there. She went to work for DuPont after her master's. So after I finished my PhD, I went to work for DuPont, because in Delaware, if you do a PhD in engineering, it's state law, you have to go to work for DuPont. It's like military service, So was there for 6 or 7 years. And then I always wanted to be in academia. And I enjoyed teaching even as a graduate student and thought I was good at it. So I thought I'd get some experience first. That turned into about 6 or 7 years at DuPont. And then I had an opportunity at Virginia Tech. They were starting a new macromoleculars institute down there. At this point, I was still a chemie. I hadn't done much materials other than the fact that DuPont is a materials company, basically, and I was working in Kevlar and then in automotive composite materials. So I was doing a lot of materials testing. And that was my first entree into materials science. I'd really not taken materials science courses as an undergraduate or a graduate student. I was doing thermodynamic phase diagrams in graduate school. So when I got to Virginia Tech, it was in the material science department. So of course our department head said, "New faculty member, you're going to do the intro course." So I ended up teaching Intro to Material Science, having never taken it in my life. So I learned it really quick and took materials and taught materials, and then polymer processing, polymer engineering was what I was basically teaching at the time. Did that for about 11 years, and then had an opportunity to move to James Madison University in Virginia because they wanted to start engineering there and they didn't have it. So I got hired, and I got to be the founder of their engineering program, which was awesome. So I got to hire all the faculty from scratch, build the labs from scratch, build the curriculum from scratch, get it through ABET, the whole bit. So this is part of the story, because what we did was we built a general engineering degree, had 8 semesters of design in it, and it had 1 semester of business school courses embedded in the engineering program.
Okay.
So we got it started, and everybody in the state told us, with Virginia Tech and UVA, you're going to crash and burn. You're never going to make another engineering program fly in Virginia. But by building that very unique kind of general engineering with business and design, last time I checked, they had 500 students in their program. So I think it worked. And so that was really successful. We got it through ABET. And at that point, what was Philadelphia University at the time is now Thomas Jefferson University. The president and one of the alums wanted to start a college that had a combination of design, engineering, and business in it. And they started looking around, and they found me down in Virginia doing that school that had design courses and business courses and an engineering degree. So that got them to try to recruit me to come up and be the founding dean for the college there. So that led to the formation of the Kanbar College. Maurice Kanbar was our alum donor. He was a serial entrepreneur and inventor. And when he invented really cool products, he said his design teams explicitly would have designers, engineers, and business professionals on them, because he needed the designers to really understand what would be desirable to a potential customer, what were their needs. He needed the engineers on that team to take that design concept, reduce it to practice. What are the materials? What are the processes? What are the technologies that'll make it happen? And then he needed the business professionals on that team to say, well, how do we turn that product into a sustainable business? You know, what are the economics? What's the supply chain? What's all that? So that's what we did. We brought all those majors together, but we had to figure out a way to get them to talk the same language, right? So the idea was put them together in several classes in a core curriculum that would teach them common skills that you needed to succeed in industry, whether you were a designer, a business professional, or an engineer. And it turns out those are the basic, what people pejoratively say are soft skills, and I hate that word. I call them professional skills, because they're harder than the engineering skills. And you guys may have heard me say that my universal engineering blessing to all of my engineering students is, may all your problems be technical. Because as soon as you get humans involved, that's when it gets ugly. So these skills associated with working in teams, how do you deal with leading from the front? How do you deal with leading from behind? How do you know how to negotiate that? How do you know how to adapt when the rules change and the objectives change? And how do you create new ideas from scratch? So there's all these skill sets that have nothing to do with which discipline you're in. So we built a core curriculum. And ironically, what's happened over the years now is that even in our engineering program, which isn't that large, it's with the smaller of the three groups is our engineering program. But our engineering students get hired at 100% every year. All of them get hired. And when you talk to the alums or the companies that hire them, you find out that those are the skill sets that are getting them hired. The engineering skills are necessary but not sufficient to get hired. And especially in our disciplines, right, ABEC accreditation, a transcript from, say, mechanical engineering or whatever is going to look about the same at every school, because the fundamental courses are going to be the same, right? So that gets you the ante to get in the door. But what they're going to want to know is, what else do you know how to do? How are you going to be able to contribute to this organization? And that's where those professional skills are going to differentiate you. And you both have heard me say this many times, universities haven't figured out that universities are no longer about the information, they're about the experiences. And the information is important, yes, but the information is cheap, right? If you don't need to go pay $40,000 a year to figure out how to solve a second order differential equation. You can look that up on Google in 3 minutes, right? So what you're really paying for are those experiences that the faculty bring, that the experiences in labs, experiences that they have in internships because the faculty have connections in industry. It's all that skills that they build that are above and beyond the fact that they have the engineering technical skills. So that's really what gets them hired. And we realized that was really the leverage of our program, was not the degrees. If you graduate as an industrial designer or a fashion designer or a mechanical engineer or an accountant, it was that other skill set that was getting you the jobs. So that's what really led us to focusing on how do you blend these professional skills into the context of your discipline in a way that they're not separate. Because even many schools don't even teach any of them. But the schools that do teach those things usually compartmentalize them in maybe general education or somewhere where they're separate from the curriculum, the important quote unquote curriculum, right? This, since it's part of the core, is integrated into your curriculum. So like one of those 4 courses where we teach this stuff is the capstone. So every program in their capstone has to incorporate the stuff that we teach in the core. So if you're an engineering student, you have to do a business model. You have to do things that a designer would do to look for customer inputs. Like how do you do qualitative research to find out if the change you're making to the product you're building has an audience, right? If you're a designer, you can't just say, I want to make it out of plexiglass. You've got to do an engineering selection and say, why do I want to pick that material? So you have to use the other disciplines. And One of the interesting things that happened from that, in my opinion, was that since the students had to take these classes together in mixed classrooms, they built a peer network of students in the other disciplines. So they started to serve as each other's consultants on their capstones. So like you're a senior and you're in engineering, you say, yeah, I got to do that damn business model. Wait, there was this kid that was in my group when we were sophomores, was really good at that stuff, and he's a finance major. I'm gonna go call him again. And so, which again is one of those professional skills you do in industry, right? I mean, when I was at DuPont, not once did my boss walk into my room, my office, and say, I have a problem for you to solve. You have 50 minutes, you're not allowed to talk to anyone, and you're not allowed to look in any books, right? Which is exactly how we test kids, right? It's use every resource you have available to you. I need this problem solved, right? So they really get to this point that it's okay, fine. I'm going to go talk to the kid in finance who can help me. I'm going to go talk to the kid in fashion design who knows how to get me a piece of fabric because I need a piece of fabric for what I'm building, right? Yeah, they learn really quick, and that's that fast start that they get when they're in industry then, because they can incorporate in a team. And the skill set that industry has told us about that they're most interested in is, I half jokingly call it this weird mix of arrogance and humility. Because when you're on a team, and you guys know this, you have to know when to have the guts to stand up and say, that's me, I know how to do this. Even if you're not the lead of the team, say, I know how to do that. Let me take the lead right now. I'll tell you guys what you need to do. I got this for us. And then you also have to know when it's like, no, not it. It's not me. I'll be a set of hands, but somebody else needs to be the lead on this thing because I don't understand it, but I can help, right? And they do that like that. And to me, that's the skill set that gets you a job and it makes you a leader in your profession, not just a set of hands. And nowadays with AI and all these other tools that are available, if all you are is like, the best CAD kid in the world, I can buy that for $2 an hour in Bangalore, or I can do it on AI, right? But if you know how to systems integrate and you know how to pull the team together to get a job done, and you know how to motivate that team, and you know how to communicate the results of your team to a decision maker in a way that gets them to make a decision and do something like invest in the product, they need you in the building. That's not something they can outsource, right? And so more and more, the technical stuff is necessary but not sufficient in today's society.
Yeah. There's so much in that answer that we could spend the whole episode just talking about any one of those things. It's such a rich topic. I do have to mention, though, that the more of these interviews that we do, the more we find out that there are a lot of people who fall in the boat of, and then I found myself teaching materials, having never taken a materials class. It's almost normal in our community, but I think that's because we bring in so many different kinds of people. There's not one road here. And that's something that I hope our students take away from the degrees that they get in materials, is that they should be interdisciplinary. They should be open to opportunities. And to the point about professional skills, they should be people. Their smarts is not what's going to qualify them to succeed in the world, nor will their grades for that matter.
Yeah. And if you look at the educators that are at this conference, they all know how to communicate, right? Most conferences you go to, the presentations are like voluntary root canal, right? Sometimes, right? You know what I mean? But these folks actually know how to articulate what they're doing in a compelling enough way that you want to listen to what they have to say and are excited about what they're saying because they're excited about what they're doing. That skill set alone is something that most students don't understand.
So you said something that really resonated with what I've seen in the last few days at NAMES. There's been a lot of talks, I think you might have even done this in your talk, that pointed out that, we all learn material science, the linear approach, the Van Vleck, the Callister approach of doing bonding and crystallography and the science approach. And it seems that what's emerging is let's come from the application side, the design side, and go back down. And I think that really resonated with me through this whole meeting. And I think our community is starting to think that way. And I've not seen that before.
Yeah.
This is kind of new. And, I worked in industry for a short period of time, and it's what's always made me cynical about courses, right? Courses are highly overrated. And I think even Tim in his talk said, well, we're academics, so we have a problem. We got to teach a course.
Yeah, that's right.
And it's like this knee-jerk reaction that really may not have a role. And now with the whole question of what is a textbook, with AI, with the web and all of this, we have to rethink everything. And when I come back to it, it's what you just said. When you're on a team trying to design something or tackle a problem, it doesn't matter what courses you took. There's going to be stuff that you never learned
Right.
anyway. And so you have to have the skill of figuring out what you need to learn, who's the best resource to help you, how can you gather whatever resources you have to get the job done. That's what matters.
Yeah.
And that's really defines that skill set. I too hate soft skills, but I almost call them human skills.
Yeah. That's another good phrase. Yeah.
Because it's how to talk to humans, how to interact with them, how to work and play nice with others.
Yeah.
That's such an important skill
Yeah.
to acquire, even if you're a real curmudgeon-y jerk. You have to learn how to
Yeah.
overcome that
Yeah.
because you won't succeed without it. But I really love the way you've been doing it. It reminds me also of what Olin College
Yeah.
has done.
Yeah. Very much so.
That's a different model. That's a project-based model. But I was at a conference and I met a guy who had been the provost at Olin. And he left Olin because he wants to start a new school that has more of what you're talking about in it. So I should probably connect you
Yeah.
guys.
Absolutely.
So
Yeah.
anyway, I don't know. Do you get the feeling that more people are coming around to this kind of approach to educating students, especially in the presence of AI and what's
Yeah, I think they are. I think most people now understand, many people now understand that you have to start at the application side and design first to get into the engineering questions. I mean, I think another thing I said in my talk was one of my favorite moments is when the engineering students realize that the best solution is never the best engineering solution. That it's always attenuated by design or cost or aesthetics or customer desire or something, right? Or I want it to be purple, right? Or whatever, and yeah, so that's why we do a lot of what we call sprint projects. So we have a lot of industry come in. We're lucky that a lot of our alums from our design programs, especially, are in like Ring and Shark Ninja and Nike and Under Armour and these companies and Lockheed and so they'll bring problems in and we'll do these 2-week sprints where we just suspend the curriculum and you put teams together and for 2 weeks they do nothing but eat, sleep, and drink this problem. And they have to come up with a design possible solution and then present it back to the company in 2 weeks when they come back in. And it forces them to address the stuff they don't know, like you brought up. It's that you never know enough about that problem to solve it. So it's how do you move it forward and come up with some ideas that are plausible, that you can defend with basic science and engineering, but are not perfect yet. And that is what I think drives that process better than starting with the basic science and then in the last week of the class saying, oh, and here's an application, right? And it's our faculty have flipped on that. And we built our building after the curriculum. So we got to build the building to match our curriculum. So it has all these studio spaces. And we teach almost all of our courses in studio mode instead of in classroom mode. And I knew we were successful when I was walking down the hall in our building and there were 2 history professors looking in the glass window of one of the studios and trying to decide how they could teach a history course in a studio model. And it's like, yes, that's every concept, any topic that you want to teach could be taught in a studio model rather than in a classroom traditional course model.
That's right. And I think that would, in some ways, help with the relationship between the STEM and the non-STEM fields on campus. Is STEM classes have a reputation for being hard, partly is fair, but it's a lot of us teach engineering by having our students do engineering. And if historians were teaching history by having students do history,
Yes.
they would appreciate the rigor of that field and how challenging it can be
Yeah.
in a way that I think a lot of students don't realize.
Yeah. And the other problem we have with, I'm going to sound old when I say students nowadays, but is, and this isn't, I don't mean to be negative here, but they're rather brittle in the sense that they don't do well with failure. And if they make a mistake or a problem doesn't work the first time they do it, they really have trouble. They really have trouble with that now compared to 10, 15, 20 years ago. So I think the other thing about this approach is that they have to repeatedly fail, and it's okay. And you know,
develop resistance to that experience of I failed, and now I'm going to get on the horse and do something else, and it'll be okay.
It's resilience, you know. And I tell the students, you know, you're going to do research, and it's called research for a reason. Look at the word research. Search again. If it worked the first time, it would be called search, right? Since, you know, you search, then it doesn't work, then you research, then it doesn't work, then you research until it works. So you're right. In building that, and your point about what assignment they are given based on like what their discipline is, that was a shock to me when I got hired at DuPont, chemical engineer, bachelor's and PhD, doing phase diagrams of supercritical fluids. I got to DuPont, I sat down at my desk, the first assignment was a circuit design. The right answer wasn't, excuse me, I'm not an electrical engineer. You suck it up, you pull out your circuit book, you figure it out, right? The guy sitting next to me was from a major university, I won't name the school, and got hired the same week I did. And like 6 or 8 weeks in, he comes to my office and he said, this sucks. I said, what's wrong? He said, they haven't given me anything to do yet. And he was like sitting in his office waiting for them to tell him what to do. And it's like, you're a PhD. Your job is to go figure out what you can do to contribute to the company. You don't wait for them to give, it's not like you're an undergrad and they're going to give you a homework problem. Go figure it out, you know? And yeah, it's just, it's amazing how many people don't, it's hard to separate this like book intelligence from social intelligence, right? I keep having to remind myself the two aren't correlated.
Right.
And just because you educate somebody in a traditional sense, they don't develop that social intelligence,
right,
to teach it.
So on the sprint model again for a moment, and connecting it to the situations that people encounter in the workplace, I have to imagine that turns out to be a much better assessment model also compared to exams, because you're right, your boss doesn't walk in and say, fill this out in 50 minutes, go. It's, our client just came to us with a problem, I need an answer for them yesterday, get your best guess as soon as you can. So do you find that works well for assessing students also? It's incredibly effective at assessing students, and it is what gets them their jobs. If you think about it, so we had Target come in, and Target asked a brilliant question. They said, design products for back to college students, for yourselves. So the students went through a 2-week sprint. They designed like 15 or 20 different products. Target came in with their manufacturing partner and went through them and said, we like these 3. And we want you to take a year to deep dive on these 3. And they actually designed the full product. They manufactured it and they sold it across the United States in Targets. They made $750,000 off of those 3 products in one summer, and the students got royalties. Now, you're that kid that was on that design team, right? You go in for the job interview, you slide your resume across the table, and then you take the package and you lay it on the table and said, I designed this for Target and we sold it last summer.
Right. Yep.
Mm-hmm.
That's great. And what you're saying about what a PhD needs to do in a job is so right. I mean, a company hires you so that you can help that company make money.
Yep.
Period. That's what you do. And if you don't want to do that, then you can find something else to do, and there's plenty of other things to do. But you have to find a way to add value to the bottom line of the company. And it's amazing how few people understand that.
Yeah.
And how few faculty understand it, because most faculty have never worked.
Yeah, they've never had a real job.
They've only been at a university.
Yeah.
And it doesn't take long to figure this out, but you should at least figure it out.
Yeah.
And, but it's also in my old age of watching my friends start all these companies, engineers start companies. I notice that, the vast majority of them fail.
Yeah.
And when I find out why, it's because they're missing one set of the skills or two sets of the skills that are important, that are exactly the ones you brought up.
Yep.
One of my students, raised $200 million of venture capital and started a company. He invented all the technology. He knew all the engineering. He also knew all the public policy, all of it. He was expert at public policy, but he had to hire other people to help him with the business. And that's what sunk the company, because they didn't have a strong enough contract with one supplier who called their contract at the worst possible time.
Yep.
And it was just tragic to see, because it was such an amazing company.
Yeah, and supply chain is what will kill a company faster than anything else. Yeah. And if you can't build the right supply chain, it doesn't matter if you have a cool product.
So if you're going to be an engineer, you've got to learn about that stuff.
You better know it.
It's not, you're right, it's all siloed. I mean, at Michigan, we have a lot of experiential learning, and we're trying to work on all these human skills. We just did a podcast with Tim's colleague who does all the technical communications, and the guy's amazing, and our tech com people are actually scientists who then became English majors later. And so they actually understand a lot of what we do, but it's got to be more than that. And that's kind of the same what this guy from Olin's trying to do.
Yeah.
He wants to bring in more of the business skills, the design skills, along with engineering, because you need all of it.
Yeah. And you made the point that I say at open houses and at orientation all the time. And parents who work for a living get this immediately. Companies no longer hire you for what you know. They hire you for what you can do. Because 100 years ago, information was hard to transport. So they would hire you because you're an expert in X, because there was no other way to get that information than to hire you because you knew that thing. Now, no, you don't need that. So they're never going to hire you just because you know something. Right. Demonstrate what you can do. Because if you don't, and that's why I think our programs we place across the entire college at 97.5% within 6 months of graduation in discipline. It's not working at Starbucks. You're in your discipline or in graduate school, in your discipline. Within 6 months of graduation at 97.5%. And you tell a parent that's why they're going to send them. Because, yes, universities are a place that you find yourself as a student and you learn about yourself and you mature. But ultimately, they're paying that money so that the kid isn't going to live in the basement when they graduate, right? It's how do you get a job and sustain yourself? And that was sort of a negative way to say it. Parents want to see their kids succeed. Yeah. And they want them to be successful and happy. So if you can't execute on that, and you're right, you can't do it by tweaking around the edges of the curriculum. Right. You got to blow it up. We're lucky. We got to start the college from scratch. But you got to blow it up and just embed it. It's got to be the ethos of everybody. I think I was telling you this, before we started teaching, I actually brought in Second City and we did improv training with all the faculty, because that's the ultimate team building skill, is understanding how to work as a team. And to this day, 14 years later, we'll be in faculty meetings trying to hash out something in the curriculum, and people will bring up the exercises we used to use. Like, let's use yes and on this one. Let's use string of pearls on this one. And these are improv exercises that help you build a consensus as a team on something. And then we started putting them into the core. So you can do it with the undergrads.
So I'd like to switch gears a little bit.
Sure.
And bring it back to materials.
Sure.
So how do you envision a material student being educated about material science in this environment? And probably more importantly, how do you educate designers and business people about material science?
Yeah.
That's challenging.
Yeah.
How do you approach that?
So in my opinion, and maybe I'm biased, it's easier to do this with material science than with other engineering disciplines for a couple reasons. Material science is inherently interdisciplinary to start with. Chemistry and physics and all these other things that are in it, right? And it is more central and tactile to day-to-day life than most other engineering disciplines. When I go like into a kindergarten or something to talk, kindergarten kids inherently understand materials. They know their plastic toy's tough. They know that their ceramic plate broke when they dropped it and their mom got mad at them. They know that there's rust on the car because it's metal. They don't understand the science, but and most humans understand materials just because it's tactile. So it's easier for me to walk in, and I teach the material selection modules in almost every major in our college. And I go into like graphic design. They have a semester where they learn packaging. And I go in and do material selection so they can like quantitatively make a decision on why are they picking cardboard versus plastic for their packaging. We have a program that does surface printing, and they wanted a material science, a whole semester course on the substrates, because they print on metals, they print on ceramics, they print on plastics, they print on fabrics. And they wanted to understand the science behind the materials and what the inks were doing when they hit on these things with surface tension and all, so that they could quantify what they were doing. So designers in textiles and in fashion actually want to understand material science more than they want to understand the physics behind, say, mechanical engineering or aerospace engineering or stuff like that. And our field is more of a mix of qualitative and quantitative understanding than a lot of other engineering disciplines. So there's a lot of things in engineering that you cannot teach if you don't understand calculus. And there's subsets of things in material science that way too, but there's a whole host of things in material science that are accessible without understanding the basic math and physics. And I think one of the things I'll do when I walk into a classroom with students that are in design or in business, I'll find a spot in the room where there's a wooden surface and a metal surface. And say like a window frame or something like that that's metal. And I'll just have a student stand up, go over and say, put one hand on the metal, put one hand on the wood. Tell me which one's colder. Everybody says, oh, the metal's colder.
The metal's colder.
And I said, think about what you just said, right? Everything in this room is at the same temperature.
It's called room temperature.
Yeah. And so I said, well, why do you think that? So I said, what are your fingers? Your fingers are not temperature sensors. Your fingers are heat flux sensors. So what's heat flux? Well, we can talk about what conductivity is. So thermal conductivity of steel versus thermal, so it's sucking heat out of your hand faster. Your brain says, oh, it must be colder if it's taking heat out of my hand faster, because it doesn't understand the difference. And so you can start like in places like that, or like talks we heard about today about food. Yep. You can start with things that people really understand, and viscoelasticity, complex subject. You can put a weight on a piece of Velveeta cheese and understand how it changes dimensions in time, right? So we have an advantage, I think, a huge advantage in material science, that we can incorporate those other disciplines and reach out to them a lot easier than the other engineering disciplines can. We don't take advantage of it. We're in such a good position to do that, and we just don't take advantage of it.
So here, let me ask about that actually, because certainly at institutions that are a little more academically oriented, we have very much the classical canonical MSc curriculum. It's metals and ceramics and polymers, and we have structural and functional materials. Here's your degree, go forth and engineer. And there are so many other areas that materials are vital to, like textiles, for example, that we were just talking about. What do you see as the opportunities or maybe the necessities for materials programs that are teaching, I'll say, mid-20th century metallurgy, more or less, to find all of these other ways to connect with students who are engineers in mindset, but maybe don't see themselves in these traditional programs?
Yeah. A great example of that, I think the canary in the mine shaft, if you will, is biomedical engineering or bioengineering. If you think about that discipline, right? They did a really good job when they started to establish themselves by focusing on what they do to help humanity first, and then go back into what you have to learn to do that. This is where engineering falls down and material science falls down. If we advertised, if medical schools advertised the way we do, they would say, you should become a doctor because you get to study anatomy, physiology, right? No, it's what we do, right? Oh, you're engineering, yeah, good at physics, you get to take math, you get to do statics, you get to do... No, when you're recruited to medical school, you're gonna save lives. You're gonna help humanity, you're gonna save lives. And oh, by the way, in the process of doing that, you gotta learn physiology and anatomy, right? That's what we should be doing. It's like, look how we can solve the world's problems, and then back into what you have to learn in order to do that, right?
So how would we redesign a materials curriculum exactly that way? I mean, there's many areas I would imagine you could think There's all of the myriad of sustainability problems that materials can have a huge impact. There's all the myriad of biomaterials, things we can do to help people have better lives and to save lives. But how would you build a career? There's so many things that we can do that it's hard to focus on just one.
Yeah.
So how would you do that other than tell the students they're going to have a massive rotation of opportunities to try it out?
Yeah. Well, that's a good question. I think the person that solves that is going to be pretty famous. I mean, I have thoughts, but so I think the problem is where's the sweet spot between depth of knowledge and breadth of knowledge, right? So I think what we get hung up on is if you picked a couple applications and focus on those for a whole year, people on the faculty would be upset because their specific area didn't get hit on that year, right? So how do you get around that? I think you have to go back to say, what are the real and fundamental set of things you have to understand? Real, not what we think they are. What are the few things you have to know that if I don't teach you about thermoplastics, but what we've done combined with what you understand in basic science and physics is enough for you to be able to reconstruct that knowledge when you need it 5 years from now and figure out, just like I had to figure out my circuits, right? So it's self-learning. It's can you scaffold yourself and learn we focus too much on thinking, oh, we got to cover everything. Now we got to cover enough that they can fill in the blanks later on.
So maybe we need to go back to the original model of academia before that horrible thing called administration showed up. It used to be students would show up, find a faculty member, and pay them money.
Yeah.
The faculty member would then pay a fee to have a library. And that was it.
Yeah.
There was nothing else.
And usually that student brought a problem.
That's right. So maybe we need to go back to that model and have students come in, shop around and find some really impactful things they want to do. And then talk with an advisor who will tell them, what a great idea, but here are the fundamental things you need to learn to be able to solve it. And then they go shop to the faculty member who can help
teach
them.
me that, teach me this,
teach me this.
Yeah.
I don't want a whole course in it. I want to know just enough to solve my problem. And maybe that's the way to.
That's an interesting way. So the metaphor to that is, so as you guys know, I'm the founding dean of this program, but I'm recently retired, right? One of the things I want to do is learn piano in retirement. You think about how a person, an adult especially, is going to do that, right? It would make no sense. I would get demotivated if I spent a year and a half doing nothing but music theory. But then again, I can't sit down today and start playing songs because I don't know enough. So it's this weird combination. You learn a little bit. As soon as you learn a little bit, you can start playing simple songs. Then you get excited. And then you say, you start playing a couple songs. Then you pick a song and say, oh, wait, that has something in it I don't know how to do yet. So now I'm going to go back and do a little module and learn how to do that one thing. And then I'm going to be able to play 3 more songs. Yep. And then once I can play those 3 songs, I get excited. And then I want to do this song. Oh, I'm missing that thing. Go back, do a little bit of theory, then, right? And I think that's the metaphor for how we should be doing this, right? It's that balance between let's do problems, and when you run into the hole, go learn that thing.
Yeah.
Right. That's how a lot of language learning works as well.
Yes.
I have this communication problem. I need to express a need or a desire to this person. I have to learn those 5 words in order to be able to get my idea across. And then you go learn those words, and then you come across the next problem, and so on and so on and so on until eventually you're competent.
Yeah.
And our classes could really benefit from that sort of model of, here's a problem that is worth solving. What's the minimal set of things that is necessary to make a reasonable attempt at solving this
So
problem?
the 2 things that prevent this from happening, in my opinion, are the faculty member is no longer the expert because that student's gonna come to you with stuff you don't know either. And most faculty are very uncomfortable when they're not the expert, and they're not gonna be in control anymore. The student is in control of that journey more than the faculty member. They're a coach. And you could say, go to the library and learn this thing. They might not do it. So in our model, in the U.S. model of faculty, how do you assess that faculty member now for promotion and tenure, right? Did they do their job? How do you measure whether they did their job, right? This gets really interesting now. How do you assess a student? Did they succeed? Did they have to solve the problem to have succeeded? Or, so I think that our organizational structure in universities is what's holding that back, because, yeah.
Well, and I think what drives what you just brought up, this problem, is that we're so obsessed with the diploma mill grading model that we also think that all of our evaluation metrics have to be quantitative and objective.
Yeah.
And that's not realistic either.
Yeah.
We get evaluated on subjective measures all the time by everyone in our lives. Yeah. And there's a big difference between something being subjective and something being unfair and biased. We can be subjective, but still be rigorous and thoughtful and reasonable about it. But that has to get us out of this, I need a 90 to get an A mentality that carries forward to faculty.
Yeah, and the difference there is the difference between equivalent, equitable, and identical. There's this knee jerk to say, well, treat everybody identically, and that way we won't get sued, right? Whereas really, you only need to treat people equivalently, but it's harder to measure whether I've treated you equivalently to you, even though I've treated you differently than each other, right?
So maybe faculty should be assessed and graded based on what happens to their students.
Yes.
It should be the student success is really all that should matter for raises, for the, tenure and promotion. Show me your cadre of students. What have they done?
Yeah.
And if you do it that way, you're kind of right back on track.
Yeah.
And of course, there's also at research schools, there's research output, and that's fine. You should be able to choose what you want to be assessed on.
Yeah.
And they should leave the research faculty who don't really care about teaching. They shouldn't be teaching.
To do that, right.
And those who care about teaching should do teaching. And those that want to do both should be rewarded quite handsomely.
Yeah, and I've always said that my other weird metaphor is that, if Hollywood was run the way universities are run, then every actor would have to also be a cameraman. Every cameraman would have to be able to build sets. Every set maker would have to also be able to cater food, right? You expect every faculty member to do all the jobs, right, equally well. When it's like, why not just let the actor be the actor and not have him run a camera? And why not let the person behind the camera doesn't have to act, right? Well,
we saw that last night we had a banquet at the Atlanta Puppetry Museum. And we got to hear from the people who make puppets, repair puppets. But I was really impressed with the woman who's actually a material science undergrad, but she had this whole career that she's continuing where she makes the puppets for stop motion Hollywood movies. And she knows everything about how to make them smile or do everything. But I just assumed that she did the animation. And I went up and asked her questions. She said, oh, no, I don't do the animation. I just make the puppets. That's all I do. So that's a whole nother thing for the person who's doing the animating. And, there's a reason Hollywood movies cost so much money, because they hire so many people, because everyone has their piece.
And we have the same problem in assessing students that we have in assessing faculty, right? We expect every student to graduate and have learned everything equivalently to every other student. What if a kid excels at crystallography, but sucks at thermodynamics? I don't know, is that okay? It's okay if their career ends up being in an area where they're going to be that, right?
I told you that story. I had a student who was not there, and we asked, where is he? And someone explained, well, he got drafted into the National Hockey League, and he's playing in the playoffs right now. We did a good job educating him. He did fine.
And I think that's we're getting to philosophy now, but I think one of the problems is we don't back off and realize that the goal in life is to just die happy, right? I mean, it's not that complicated. Right. And all of this stuff we go through in training and education and the pressure we put on people to make decisions about career paths and stuff like that. I mean, if anybody tells you they have their career path planned out, they're lying to you and themselves, right? It's serendipity. It's plan and adapt. And if you can teach that adaptability, and if the kid never touches what you taught them in college, but they've learned those professional skills again that made them successful and they're happy when they die, we win.
So this brings up an interesting point. Where in your curriculum do you teach students how to do that? Where do you teach them how to learn? How to learn in a reactive mode than as opposed to a, to a mode where they're starting from scratch and follow some absurd linear path. It's how do you teach students to be facile, to be adaptive, to go figure things out, and that's a very different skill than studying for an exam.
Yeah, and we have a model close to us that sort of goes in that direction. Think about what we do with our grad students. We basically do that with grad students because we think they're quote unquote now mature enough to do that. But I think we underestimate the undergraduates. You could literally take most 18-year-olds and just start there. And it would work. I almost guarantee you it would work. And the artificial 4-year thing is also a problem, right? Some people are going to do this faster than others. Some people are more emotionally mature at 18 and they're going to be fine. Usually our female students are better off than our male students at 18 years old. That's just a physiological thing, and it's okay if it takes 5 years to do that. Right? I mean, I think we have to take the pressure off of people. It's a marathon, not a sprint, right? I mean, and again, this
don't sprint the marathon.
Yeah, and it's that, if our goal is to make people successful in life, then going full circle to what you said, I think material science is a really great place for that because it is so connected to human life. We heard how many talks today about how you can teach materials as a subject to humanities and other disciplines because every era of humankind is named after a material. I mean, materials impacted most decisions that have happened in the world, and it's so easy to link materials to history, materials to society. And it's like, it's there. It's way easier for us to do it than other disciplines. I don't know why we're not doing it.
Yeah. As long as we're doing our best to teach or at least prepare our students to be successful and happy in life, let's come back to this leadership theme for a moment, because the knowing when to stand up, also knowing when to sit down, and ideas like this. What you presented at NAMES was about a leadership development program that you've gotten off the ground. So can you tell us about that for a few minutes?
Sure. So we took that core curriculum that I mentioned earlier, that sort of the common language for all of our majors to speak. And we realized that a lot of the skills in that are inherent leadership skills. And so we started to muse about the idea of, can we turn that into something deeper? Instead of just introducing them to those subjects, could we really give them a deep dive into those subjects? And we had everything but the money to do it. And then fortunately, a benefactor, and I didn't say this in my talk, but he was the chair of the board in 2011 when I got hired. So he was the champion for starting our curriculum, starting our college, for having me do this. And so when we came back to him now later in life and he was ready to make some 7-figure donations to amp up what he started into something even bigger, he just jumped at the idea. So what we did was build a 2-year experience that's very honorific, if you will, in the sense that you have to be rigorously selected for this program right now. And we'll take 10 students in it at a time. And it is a 2-year deep dive where, much like we were saying, it's not structured curriculum as much as it is a set of experiences where they can explore what they need to learn to be better leaders. So we have them do things like interview CEOs and C-suite people, and they have to come up with how they're going to interview them. We don't tell them how to do that. So they have to organize among themselves and figure out who's going to ask what questions, who's going to describe what this program is and why we're talking to this person. And we give them the guys or gals bio, but we say, hey, go look them up on LinkedIn, go figure out who they are, understand what you want to ask them. And we always pick the first couple to be people we know that are very compliant, so that if they don't do it so great, it's okay. And then they develop over the 2 years they're in the program that ability, that self-confidence to start expressing leadership skills in front of people that they don't even know. And I think that every one of us has imposter syndrome. And I think you just have to admit it, and you have to say, how am I going to use it? And what I've seen is there's 2 approaches people take. And there's one that is very damaging to you in career, and one that's very good for your career. And if you respond to your imposter syndrome by saying, I'm going to prove to everybody in this room I'm the smartest person here, you're in trouble, right? But if you say, man, I shouldn't really be, I don't think I'm qualified enough to be here, I'm going to work my ass off, and I'm going to be the first one in the morning, I'm going to be the last one to leave, I'm going to double read everything I've been asked to read, I'm going to do extra research, right? If that's your motivation, I'll show them I'm going to work harder than everybody else, then you succeed, right? So they learn that from each other. And so it's that experiential piece of building that skill set over 2 years now. So it's longitudinal, which is really good. And since there's juniors and seniors in the program, there's a lot of peer-to-peer education. The seniors have been in the program a year already. When the juniors enter the program, they're brand new. And this goes back to something when we were talking about how to build the whole curriculum. We throw them into these CEO interviews immediately. And I've always thought the biggest mistake we make with freshmen in all disciplines, but especially in materials, we give them an oversimplified problem to start with. We throw the ugliest problem from industry at them from day one. It's okay to expect a less sophisticated answer from a freshman than from a senior, but you don't show them a simpler problem. You let them see the whole bloody mess. And that's kind of what we're doing with this leadership program, is we're immersing them in the whole bloody mess from the day they start the program.
And then I imagine this also communicates to them, you might not succeed, or you might not excel at this, but I expect you to give it your best based on what you can do right now.
Yes. And tell us how you're going to get better over the next 4 semesters. And every semester we ask them, so what worked and what do you have to work on next semester? Like what skill set don't you have? And then we answer the question too along the way, because there's stuff that I still don't do well. I've been doing this for 45 years. Scary to say, but 40 years at least, yeah. So, but yeah, and I think that as soon as you think you've got it mastered, you're done for. So, that leadership program is 1 year in. Been very, in my opinion, pretty successful in the first year. There's a lot we could do better, and it's going to be interesting to see how the second year goes.
That's awesome. So we're getting close to an hour, and so we always like to ask our guests if there's anything you'd like to add, anything you'd want to sell for yourself, for your institution. I realize you're winding down, you're retiring, but even if there's nothing you want to sell, what's your vision? What do you think is going to happen to the future of materials education in the United States? Because, everything we've talked about, universities are not in a good place. They're not in a good place for a whole lot of reasons right now. So it's actually a time that could really lead to significant change. And where do you think that change is going to happen? Because it's not universities who will decide this ultimately. It's our students who are going to decide.
Society at large.
Right.
Yeah.
And so what do you think things are going to look like 10 years from now?
So, okay. I'll start by saying that the fact that it's changing so rapidly right now with external forces and internal forces is an advantage, because when things are stagnant, it's very difficult to change. When somebody upsets the apple cart, that's when you have the opportunity to go in and make massive changes. So I think where material science and engineering is, our traditional approach has always led us to have the smallest cohort in the College of Engineering, right? or second smallest, right? Or whatever. So we should take advantage of this. And the successful programs that are large are not going to try as hard because they're already big. And they're not going to see that the disruption is going to affect them. So the mechanical engineering program and the electrical engineering program and those things, computer engineering, don't think they have to do anything differently. We know we have to do something differently. If there's a change happening, we should jump on it and be the first ones in to make those massive changes. And I think the changes are exactly what we were talking about here, is start philosophically with the fact that our job at a university is to have these students have successful lives. And if that's our only goal, what do they really need to know when they leave? No, sorry, I have to use my own language. What do they have to be able to do when they leave to get there? And if it's not on that list, you don't have to teach it. And that sounds like blasphemy, but realistically, I think if we had the reputation as a material science and engineering discipline, as the place you go as a student to have a successful life, like I said, we tout this 97.5% placement rate, right? So you think a parent, when they're choosing between Drexel, Temple, and James Madison and Jefferson, are looking at like ABET rankings or that kind of stuff? No, they're saying 97.5%, my kid's going to be able to take care of me when I'm 95 years old now because they're going to have a good job, right? And they push us, they push their students toward us because we basically say our goal is to have your child have a successful life. So if we could build a curriculum around that in the midst of the changes, and we're in good shape for it because like I said, we have such a tactile profession that things like AI and machine learning and it's not going to damage us in anywhere near the same way that it's going to damage some other disciplines. If we don't let, I mean, it could if we were not careful, right. But if we teach the stuff that's never going to do, and how do you leverage it as a tool and have those professional skills and have that the systems integration capability, then we're going to end up with the ones with the 1,000 students instead of 100 students, right?
I think that's a great vision for what material science can become. Hopefully, we'll see that happen in the next few years.
Amen. It's folks like you that are going to make it happen.
I accept this responsibility. I guess we should wrap it up for the moment, though. Ron, it's been an absolute pleasure to have you on the show. Thank you so much for coming and sharing your thoughts with us.
Thank you so much. This has been a really fun conversation.
Great. And to everyone out there on the internet, wherever you are, of course, we'll see you next time on the next episode of Undercooled. Bye, everyone.